Hello, hello. My name is Apivit Denpruktham. I'm from electrical engineering.
Hello, my name is Phuritat Pahala. I'm from mechanical engineering. And today we're gonna present
Our lab project, which is lab 6.
this lab 6 for section 750001.
Let's get started. In our lab, we're gonna use AC and DC circuit, DC, uh, DC voltage supply, and AC voltage supply. DC voltage supply is gonna flow only in one direction. But AC can flow in both directions. In this lab, we're gonna use both of them.
So this is the oscilloscope. It's gonna measure the wave, but first we have to calibrate it first. So we check it. This is the positive side and this is negative. So we put here in this side and negative to the ground. And then we press the auto set button. It will become like this. So this is normal for.
Okay, so this is the first part of the lab, which is AC connect to the DC circuit. We VDC connect to VAC, and then we get the ground from VDC to the resistor and get the voltage from the VAC to the resistor, and then we're gonna find the uh, waveform of it.
So now we're gonna measure by the oscilloscope. So we put it out here. We have to use this to connect to this. So we gonna put it here. Positive side in the circuit, put here. And for the negative, I do the same. Yes. Okay. So in the lab, say we have to use DC selector. So first we auto set. And then we popping DC. It's already DC. It's here. And auto set again. Okay, so this is the wave. And sometimes the position is very low here. We can adjust it to the axis. And this is the time axis. This is the voltage axis.
So this waveform is two time division, which we can see from this box, which is two box to a fully one waveform, and have the voltage peak is 20 and have 20 period per 20 millisecond per one period, and the voltage diff is 5 voltage.
5 voltage per division. So how to count the division is one division, right? So it's around 3 point something.
3.8.
Yeah. So then how to calculate the voltage peak to peak? So this volt per division, we can get it from the oscillator, and peak to peak division is around 3.8. So we multiply this and this, we can get voltage peak to peak
Which is 15.4.
around 15.4. And the time per division, we say is here is 10 millisecond, and the period per division is 2. So write 2, and to get the period for the second, we have to this one and this one multiply.
Which is 20.
20 millisecond. So frequency, we can use 1 over t, but this one we have to change to second first, and it will become 50.
And for the AC calling, AC selector, we just change the setting into AC, and we auto set, and we're gonna have the same one, but a little lower because this AC selector use both AC and DC.
So the next circuit, we only use the AC source is 9 volt, and then yeah, 9 volt. Then we connect here to the 1 kilo ohm resistor, and then we use the 1 microfarad capacitor. So we have to connect to the positive side. It's only can do in this side, like in the circuit. Yeah, say the positive and then out of the negative. Okay. Now we have to use two channel of the oscilloscope. So for the channel one, we use the normal, the same, and we put the positive here and negative here. So for the channel two, yeah, it said the positive have to be here. So connect it. Here, and the negative, it say it on the same spot as the channel one. So put it here too, and then select. Oh, and for the channel two, we have to do the invert too. So
Okay, now we invert it, and then we need to calibrate it uh to the middle of the screen. After we get both of them together, we need to move the time position to the start of the waveform, which is here. Now, which is here. Now we can have the circuit like this.
we have the value for the channel one and the channel two. So it's and can calculate with the same pattern that I said before. So the channel one is 5 volt per division, and it's around 2 division. So we calculate here 5, and P to peak is 2 division,
Which
got
is 10.
10. And then for the time division, say 10 millisecond, and around 2 division.
Also
So
20.
2, and we got 20 millisecond. And for the frequency, we can use 1 over T. Same, we got 50 hertz. And then for the channel 2, it say it's 10 volt per division. Okay, so the division is
Is 2.5 or 2.3.
around 2.5. So we multiply, we get
25.
25.
Now we can get the
Competition is the same, 10 millisecond, and the period is 2. So we do, and then we got 20 millisecond, and
the hertz count the same.
yeah, it's 50 hertz.
And the delta t is the difference between two waveform from channel 1 and channel 2, which for this we can count by the slash here. It's around 5 division, 5 times.
Okay, so for the phase shift, we have this formula,
which is delta t divided by t multiplied by 360.
yeah. So the delta t we got is 5 millisecond, and for the t, we can use this as 20 millisecond, and then we divide 5 by 20, and we multiply 360 degree, and we will get 90 degree. That's the answer for the phase shift.
Thank you for watching our video of introductions about our lab, which is L006. We hope you understand our lab. Thank you.
Thank you.